Okay, guys, you are in Advanced Math Trig. We are actually in honors class and in the normal class both. Starting a new unit on sequences and series. If you are in honors, mods 2, 3, and 4, you are putting the date 4/24/20 at the top of your paper. So for you guys, it's Friday, April 24th. So any small homework assignment at the end of this section of notes will be due on Monday. That'd be Monday, April 27th at noon. If you are in Mod 7, you're going to be taking these notes. It'll be on 4/30/20. Okay, so if you're in Mod 7, in the top corner of your paper, you're going to put, Thursday, April 30th. 2020 for your date. So your homework assignment for this section of notes would be due the next day by noon on Friday, May 1st at 12 o'clock. Okay, so this is for all Advanced Math Trig students. The 30th for Mod 7. The date is the 24th for Mods 2, 3, and 4. Top of your paper, the title says, now that's not arithmetic, that's arithmetic. So I want you to write the title Arithmetic Sequences, and you're going to put a little arrow down to the first line, and you've got to write down a definition for what an arithmetic sequence is. Now, in general, let's ignore that for a second. If I just said the word sequences, a sequence of numbers is simply a list or a group of numbers written in a certain order. There's all kinds of different kinds of sequences that exist. We're focused today only on what's called arithmetic sequences. I think you guys have seen this in the past, but we're going to do arithmetic sequences, arithmetic series, geometric sequences, Fibonacci sequences, infinite series. We're going to do sums, missing terms, and get into a lot more detail than maybe you have in the past if you have indeed been exposed to this. So for today, arithmetic sequences, go ahead, I'm going to give you a minute here. Write down that important definition. It's a sequence of numbers in which the next number is found by taking the previous number and adding the common difference to it. So guys, basically we're going to be looking at a group of numbers written and separated by commas, and it's a sequence or a listing of numbers where the next number is going to always be found by taking what you notice is the common difference and adding it to whatever that previous number was. So one more time on your paper, write down a sequence of numbers in which the next number is found by taking the previous number and adding the common difference. Okay? Notice I underlined the word adding. You'll see what I mean by that in a second. All right, so let's start out with an example. Everybody on your paper, go ahead and write EX for example. And I gave a nice simple. This isn't complicated at all today. Very basic mathematics. But as we build up through this chapter, you're going to see a big bank of formulas you're going to have to memorize and utilize to find all the missing sequences, patterns, missing numbers, sums, partial sums, things like that. All right, simple example. Here we go. 2, 5, 8, 11, 14. I mean, my gosh, I could ask a first grader, do you see a pattern there? Obviously, we're what? Taking the previous number and we're adding 3 every time. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11, and so on. So 2, 5, 8, 11, and 14 is a ... an infinite arithmetic sequence. And I made a note in parentheses here. You do the same thing. It says D equals 3. D always stands for whatever that common difference is in that sequence. So since I'm adding 3 each time, there's a common difference of 3. And that's my first example of an arithmetic sequence. Now, example number 2. Go ahead and write this one. Write 4.5, 3, 1.5, 0, -1.5, -3, ... So again, it's an infinite sequence. I could go forever following that pattern. Notice it's in descending order, correct? The numbers are getting smaller and smaller and eventually turn into negative numbers. Okay, guys, never ever look at a sequence and describe it by using the word subtract. You don't say, oh, they're subtracting 1.5. If you look back to the definition, the previous number is going to get added on to by whatever that common difference is. So the next number is found by taking the previous number and adding some number every time. So aren't we adding negative 1.5? So technically our common difference is negative 1.5 because we're adding a negative number each time, and that's the only way the numbers can keep getting smaller. So those are the two just very basic, easy examples I'm going to use to point out a couple of important things today. 2, 5, 8, 11, 14, etc. And then 4.5, 3, 1.5, etc. Let's look at those two. Now, let's focus on example number 1. So on your paper, let's go ahead to example number 1. Let's put an arrow down and we're going to answer 2 questions, okay? Question 1 is simple, and I'm just coming up with things you'll see in a math book or an ACT question or something like that, college entrance exam. It's part of pattern recognition. If I said, what are the next 3 terms in that sequence? Well, of course, all you had to do is recognize that it was an arithmetic sequence whose common difference was 3. So the next 3 numbers, of course, if I add 3, then add 3, then add 3, would be what? 17, then 20, and then 23. So finding the next 2 or 3 or 4 or 5 numbers would not be an issue. The question becomes, what if they ask, oh boy, question 2 on that same example, okay, what's the 17th term? Now, I know you could get this by writing out all 17 of them, but guys, we're not going to rely on that. I could have said, what's the 117th term? You are not going to sit here and write down 117 terms just to see what that 117th term would be. There's obviously must be a formula to find an answer to a question like this. So, to find the 17th term, or the 28th term, or the 86th term, whatever term they ask you to find, put a star and a big box around this critical formula, okay? You're going to write a sub n. So I'm not finding the 17th term here. I'm trying to find the nth term. They could have said 17th. They could have said the 26th. They could have said the 85th. To find the nth term of any arithmetic sequence, you're going to use the formula a sub 1 plus parentheses n minus 1 times d. Now, when it says a sub n, in this particular case, oh, we're looking for the 17th term, aren't we? So that'd be a sub 17, because I'm looking for the 17th term of the sequence. So our n is 17. A sub 1, of course, stands for the first term. So if n was 17, I know I've got my first term for A1. N is 17, and D, of course, represents the common difference, which in that first sequence we've already determined to be 3. So with this in mind, watch this. Let's give it a shot here. If I told you now to find the 17th term of that sequence, okay, here we go. A sub 17 equals A sub 1 is the first term, which we look up and see is 2, plus parentheses, n, oh, we're looking for the 17th term. So n is 17. So 17 minus 1 times the common difference of 3. Obviously, if I went another step here, that would really be what now? 2 plus, let's do what's in parentheses first. That'd be what, 16 times 3? Remember, order of operations, always multiply and divide before you ever add. So it's 2 plus 48 for a total of 50. And I found my 17th term without having to write them all out. Okay? All right, let's go focus on example number 2 real quick. The one that said 4.5, 3, 1.5, etc. Go ahead and put an arrow down from that one. And again, I'm going to ask you what are the next 3 terms. Okay? Well, remember, the pattern was what? We keep adding negative 1.5 to get the next number. So certainly you'd agree the next 3 terms are what? Negative 4.5. Okay, now add negative 1.5 to that. So that's what? Negative 6. Add another negative 1.5 and get negative 7.5. So I found my next 3 terms. Oh boy, what's the 22nd term? All right, here we go. Let's see if I already know my formula. I'm using that a sub n formula again, but we're looking for the 22nd term this time. So a sub 22, the 22nd term, would equal, okay, a1, my first term was what? 4.5 plus parentheses. Now, we don't need to write everything in there. It's pretty obvious if that's n minus 1. And we're looking for the 22nd term. Obviously, 22 minus 1 gives me 21, right? Times our common difference of 1.5. I'm sorry, I almost messed up. That's negative 1.5. Agreed? Because remember, we were adding a negative number each time. So my common difference is negative 1.5. So guys, I've got 4.5 plus. Now careful, you might need a calculator here because we're taking 21 times negative 1.5, which is what, negative 1.5? So if I push 21 times negative 1.5, we're getting negative 31.5. Now don't write a decimal. I used a decimal on my calculator. But guys, the rule is always what? If you're finding a certain term of a sequence, you want the number that you create to fit the pattern of the numbers that are there. Obviously, they're using fractions in the pattern, not decimals. So technically, if that 21 times negative 1.5 gave us negative 31.5, I'm going to write negative 31.5. So, if I have 4.5 plus negative 31.5, I'm going to end up with what? Negative 26, or excuse me, is that negative 27? Some of you are going to need your calculators. 31.5 minus 4.5 equals, yep, keep the sign of the bigger number. I'll be darned. The 22nd term would be negative 27. Okay? All right, then the last thing they want you to learn how to do in this first section, what if they give you a problem like this? I've got a star by this, our last one of the day already. Each day is really not that bad at all. We're looking for, again, arithmetic sequences, geometric sequences, there's something called a Fibonacci sequence, and some formulas to find sums and things like that. What if they said a sub 8, now you got to know the symbols, that means the 8th term of a sequence is 15. The common difference in this sequence is 4, and they want to know, what's A1, the first term? Well, guys, once again, we're not just going to write down a number and kind of work backwards and count. Even though that makes sense and would be using common sense, that could have been A sub 81 we don't want to write 81 terms down. So do you agree to do this problem? They're looking for the first term. That's our unknown. Based on what they gave us, isn't your instinct to go back to that formula that I just said to memorize on the front of our paper? Let's see if you remember it. Try not to look. A sub n equals A sub 1 plus parentheses n minus 1 times d. Now, let's fill in everything we know on this problem. Oh, look, this says a sub n, doesn't it? A sub 8, our 8th number of this sequence, is indeed equal to what number? 15, isn't it? So a sub 8 can get replaced by 15 equals, we don't know the first term, A1, do we? That's what we're looking for, so that's my unknown. But I'm going to go plus n is always whatever this number is down here. We were looking, or we were given to us, the 8th term. So n is 8, so 8 minus 1 gives us 7 times, and then the common difference we were told was 4. Now note, since that difference is a positive numbers, the numbers are getting bigger and bigger, so it's in ascending order, isn't it? So our common sense tells us that the first number's got to be smaller than 15 if you use common sense there. So guys, we've got 15 equals a sub 1 plus, what is that, 28? So to get a1 by itself, I subtract over the 28, and certainly 15 minus 28 gives me negative 13, and I did it. The first number must have been negative 13, and then I keep adding 4 each time, and the 8th number would eventually be 15. So you can really find any of the unknowns by using our formula that was in that box on the front of the paper, okay? All right, not bad. Introduction to arithmetic sequences. All you've got to do for homework or for your assignment to make sure you got that are these 3 problems here. So I'll leave this here for a minute or so. If you want to hit pause on your Schoology video, that's fine. But sequence number 1 is 1, 5, 9, etc., ... an infinite arithmetic sequence. All I want to know, what are the next 3 terms? And then tell me what's the 31st term, okay? Problem number 2, 12, 8, 4, etc., okay? Notice that is what? Descending order. The numbers are getting smaller, so careful. The difference must be a negative number, correct? Again, what are the next 3 terms? And in question B on number 2, what would be the 19th term? Find the 19th term for me. And finally, the third question, similar to the third one I did. The 16th term of some arithmetic sequence is 33. The common difference is 2, okay? So I wonder what would be the first number of that sequence, a sub 1 equals question mark, okay? So if you're in mod 7, today is Thursday the 30th. This is due tomorrow on Friday, May 1st. If you're in mod 2, 3, or 4 in the honors advanced math trig, today is Friday the 24th. So this isn't due until Monday, April 27th at noon. Obviously, it's a quick little 4 or 5 minute assignment. Send a picture to me when you get it done on the email, and we'll kind of get rolling now with our next chapter, okay? Great job, guys. See you tomorrow.